Okay, so this topic is devoted to the basic assumptions behind the neoclassical production theory. Namely, we're gonna discuss production function and its key properties. So when it comes to production function, here you can see the very general form of this, where Y stands for the level of output, and if we assume that economy is in equilibrium also for the level of national income. F stands for production function, and basically it describes the pattern of transforming inputs into output. And two inputs are K and L, which stand for the stock of capital, physical capital, and the stock of labor accordingly. So when it comes to capital, basically it describes physical capital, as I mentioned before. So this means equipment, machinery, and so on and so forth. And when it comes to labor, it just consists of labor force, all the people in the economy who are able and willing to work. So, returns to scale can be best described by the degree of homogeneity of production function. So if we assume that production function is homogeneous to degree 1, then we deal with constant returns to scale. If it's less than 1, then we deal with decreasing returns to scale. And if it exceeds 1, then we deal with increasing returns to scale. Speaking less formally, under constant returns to scale, increasing inputs by the same proportion, let's say Z, results in the equivalent increase of output of the equivalent proportion. So increase capital and labor stock 2 times and you will get twofold increase in production level. Under the decreasing returns to scale, increasing inputs by the same proportion will result in the smaller increase in production. I mean, in comparison to the proportion to which capital and labor were increased. For instance, increased capital and labor 2 times, and under decreasing returns to scale, output will increase by less than 2 times. Finally, under increasing returns to scale, again, increasing capital and labor stock by equivalent proportion results in the increase in output exceeding this proportion. Using the same example, increase the stock of capital and labor 2 times and the output is gonna increase by more than 2 times. So here you have some easy mathematical trick which you can use in order to identify the returns to scale. So what you have to do is to assume increase in inputs, like, I don't know, multiply K and labor by the same coefficient, and then just observe what will happen to the production function. So in our case, I assumed production function of this form, which is the production function of K and L. And if I assume that capital and labor increase by the same proportion, let's say n times, I have to analyze the level of output corresponding to Nk and Nl as independent variables. In very simple words, instead of K, I put Nk, instead of L, I put Nl. Then you just open the brackets. Here you've got n to the power 0.5 times n to the power 0.7, and since we have a common base, like your result is n to the power 1.2, and this part remains unchanged. So please note that this part of the equation, 10 times k to the power 0.5 times L to the power 0.7 is exactly the original production function. So you can easily replace this expression with y of k and L, and it tells you that increasing outputs n times resulted in increasing the level of output by n to the power 1.2 times. So here, since n to the power 1.2 is definitely bigger than n, we deal with increasing returns to scale. So here you can put this video on hold and solve those exercises, and I'm proceeding with the solution. So here it is. Again, as I said before, replace K and L with NK and NL respectively. Open the brackets, simplify, and compare the result with the initial production function. It will not work for any function, so sometimes you have to do this kind of analysis, by multiplying output by some coefficient and comparing this to the output corresponding to multiplying inputs by some coefficient, but in the majority of cases it works fine. Okay, so here you have the Cobb-Douglas production function, which always takes the form A, some technological coefficient. As I said before, it stands... Oh, I didn't say this before. Okay, so in this case, A is a technological coefficient which incorporates all the factors which are the potential determinants of the output level. However, which cannot be classified neither as capital or labor. This includes quality of infrastructure, the level of technological development, stock of human capital, and so on and so forth. So, function of this form is called Cobb-Douglas production function, and here you have some simple mathematical trick which will work only and exclusively for Cobb-Douglas production function. So if the sum of upper coefficients of K and L is equal to 1, then you deal with constant returns to scale. If the sum of upper coefficients is less than 1, then you deal with decreasing returns to scale. And finally, if the sum of upper coefficients exceeds 1, then you deal with increasing returns to scale. Once again, I would like to underline that this will work only for Cobb-Douglas production function. Okay, so this is kind of the common representation of typical neoclassical production function. So Cobb-Douglas production function is just beloved by economists. Because it just has some very nice mathematical properties. It has decreasing marginal rate of technical substitution, and so on and so forth. We also assume constant returns to scale. So in this case, upper coefficients sum up to 1, which prove this idea. Alpha, the upper coefficient, stands for the degree of production function's capital intensity. So basically, very informally, it tells you what is the relative contribution of capital to the production. So for instance, when it comes to manufactured goods, they're going to be characterized by the production function describing the process of manufactured goods production is going to be characterized by the higher value of alpha. And when it comes to labor-intensive goods, like primary goods, agricultural sector, then we expect to see the lower value of alpha. Again, speaking very informally, you can take 1.5 as the threshold, especially when you analyze constant returns to scale. And I mean production function of this form. Okay, so two fundamental properties of production function are diminishing marginal product of labor and diminishing marginal product of capital. So, under following the diminishing marginal product of capital, if we assume that the stock of labor is fixed, each additional unit of capital is less and less productive. So the contribution associated with each additional unit of capital becomes smaller and smaller. Under the law of diminishing marginal product of labor, if we assume that the stock of capital is fixed, then each additional unit of labor is less and less productive. So actually you can do some formal analysis in order to prove this. So in order to define the slope of the function, you have to calculate the first partial derivative. So here you can see the first partial derivative of y with respect to labor and partial derivative of y with respect to capital. So in both cases, they are positive, because 1 minus alpha will take a positive value because alpha is always less than 1. Here you just have alpha. Yeah. So basically, those values are positive, which implies that each time you increase the stock of labor and capital, even if the other input remains unchanged, output will increase anyway. However, in order to find the rate of change of the production function, you have to calculate the second derivative. And second derivative is basically derivative of the derivative. So when you calculate derivative of this expression with respect to L, you will get the second derivative of production function with respect to L. And here you can see it's negative because here you have minus alpha. And alpha always take the value between 0 and 1. So negative alpha by default yields the negative value. The same will apply to capital because if you find the value of the second derivative, you will get alpha minus 1. And alpha minus 1 by default will yield a negative value. So the negative value of the second derivatives of production function just reflects, the law of diminishing marginal product of capital and diminishing marginal product of labor. Graphically, it's depicted here. So on this graph, I assumed that the value of technological coefficient is equal to 3. The level of labor, the stock of labor is equal to 100 units, and just draw output, against the value of capital. So this function is indeed increasing, which means that if you increase the stock of labor, which is a production input, output will increase, which I believe makes sense because capital is the production input. However, as you can see, the slope of this function diminishes, which means that when the stock of capital is relatively low, each additional unit of capital is associated with a relatively big increase in output. However, when you increase the stock of capital, each additional unit of capital is less and less productive. So yeah, this function is increasing and concave, just in line with predictions made on mathematical analysis. Same here. I assume the value of technological coefficient equal to 3 and the stock of labor equal to 50 units. And I just analyze the relationship between output and the stock of labor. Here the stock of capital is equal to 50 units, and I analyzed the relationship between output and the size of the labor force. Or the stock of labor employed, yes, I believe it will be more accurate. So again, function is increasing, reflecting the positive value of the first derivative. However, the rate of change is decreasing. The function is increasing, but at the diminishing rate, which basically reflects the law of diminishing marginal product of labor, and which was proven here based on the negative value of the second derivative. So when it comes to wages and rents, we assume that on the perfectly competitive market, wage is basically equal to marginal product of labor times price of output. But, just to simplify our analysis, we can assume that the price of output is equal to $1, which makes sense because, if we assume that output is expressed in monetary terms, then the price of 1 unit of output is exactly equal to $1. So in this case, we assume wage to be equal to marginal product of labor, or the first derivative of production function with respect to labor, and we assume rent to be equal to the marginal product of capital, or the first derivative of production function with respect to capital. So at this point, we can use this analysis in order to discuss, the distribution of income, the distribution of national income between two groups of stakeholders, which are capital owners and the labor force. Okay, so marginal product of labor is equal to the first derivative of production function with respect to labor, which we have already calculated, and this is equal to wage. Analogously, marginal product of capital, already calculated, is equal to rent. So when it comes to aggregate cumulative income of the labor force, you have to multiply the number of units of labor by the remuneration per the 1 unit of labor. Analogously, to find the aggregate income of capital owners, you have to multiply the number of units of capital by the remuneration per 1 unit of capital. So if you divide aggregate income of the labor force by the national income, and you do some primitive mathematical analysis, you will get 1 minus alpha, which is exactly share of labor force income in the national income. So portion of the national income which goes to the labor force. Again, if you divide cumulative income of capital owners by production level and do some primitive transformation, that you will get alpha. And alpha stands for the capital owner's share in the national income. So in this case, assume that production technology becomes more capital intensive. So speaking informally, capital becomes more important input. It will be associated with decrease in the value of alpha, increase in the value of alpha, and subsequently it will be followed by increase in the share of national income assigned to the capital owners. Okay, so it was that. I hope it was clear, and thank you for your attention.